Internet of Things. The Internet of Things refers to a system of interrelated, interconnected objects that are able to collect and transfer data over a wireless network without human intervention. In this course, we cover Internet of Things, how IoT works, examples of IoT, why IoT is important, benefits of IoT, features of IoT, IoT Standards and Framework, pros and cons of IoT. Internet of Things. The IoT brings the power of the internet, data processing, and analytics to the real world of physical objects. For consumers, this means interacting with a global information network without the intermediary of a keyboard and screen. Many of the everyday objects and appliances can take instructions from that network with minimal human intervention. In enterprise settings, IoT can bring the same efficiencies to physical manufacturing and distribution that the internet has long delivered for knowledge work. Millions, if not billions, of embedded internet enabled sensors worldwide are providing an incredibly rich set of data that companies can use to gather data about the safety of their operations, track assets, and reduce manual processes. Researchers can also use the IoT to gather data about people's preferences and behavior, though that can have serious implications for privacy and security. How does IoT work? An IoT ecosystem consists of web enabled smart devices that use embedded systems such as processors, sensors, and communication hardware to collect, send, and act on data they acquire from their environments. IoT devices share the sensor data they collect by connecting to an IoT gateway or other edge device where data is either sent to the cloud or to be analyzed locally. Sometimes these devices communicate with other related devices and act on the information they get from one another. These devices do most of the work without human intervention, although people can interact with the devices, for instance, to set them up, give them instructions, or access the data. The connectivity, networking, and communication protocols used with these web enabled devices largely depend on the specific IoT applications deployed. IoT can also make use of artificial intelligence and machine learning to aid in making data collecting processes easier and more dynamic. Examples of IoT devices. Essentially, anything that's capable of gathering some information about the physical world and sending it back home can participate in the IoT ecosystem. Smart home appliances, RFID tags, and industrial sensors are a few examples. These sensors can monitor a range of factors, including temperature and pressure in industrial systems, status of critical parts in the machinery, patient vital signs, and use of water and electricity, among many other possibilities. Other examples include fitness variables and home security systems. There are also more generic devices like the Raspberry Pi or Arduino that let you build your own IoT endpoints. Even though you might think of your smartphone as a pocket sized computer, it may well also be beaming data about your location and behavior to backend services in every IoT like ways. Entire factory robots can be considered IoT devices, as can autonomous vehicles that move products around and industrial settings and warehouses. Why is IoT important? The Internet of Things helps people live and work smarter, as well as gain complete control over their lives. In addition to offering smart devices to automate homes, IoT is essential to business. IoT provides businesses with real time look into how their systems really work, delivering insights into everything from the performance of machines to supply chain and logistic operations. IoT enables companies to automate processes and reduce labor costs. It also cuts down on waste and improves service delivery, making it less expensive to manufacture and deliver goods, as well as offering transparency into customer transactions. As such, IoT is one of the most important technologies of everyday life, and it will continue to pick up steam as more businesses realize the potential of connected devices to keep them competitive. Benefits of IoT. The Internet of Things offers several benefits to the organizations. Some benefits are industry specific and some are applicable across multiple industries. Some of the common benefits of IoT enable businesses to monitor their overall business performance, improve the customer experience, save time and money, enhance employee productivity, integrate and adapt business models, make better business decisions, and generate more revenue. Benefits of IoT. IoT encourages companies to rethink the ways they approach their businesses and gives them the tools to improve their business strategies. Generally, IoT is most abundant in manufacturing, transportation, and utility organizations. making use of sensors and other IoT devices. However, it has also found use cases for organizations within the agriculture, infrastructure, and home automation industries, leading some organizations towards digital transformations. IoT can benefit farmers in agriculture by making their jobs easier. Sensors can collect data on rainfall, humidity, temperature, and soil content, as well as other factors that would help automate farming techniques. The ability to monitor operations surrounding infrastructure is also a factor that IoT can help with. Sensors, for example, could be used to monitor events or changes within structural buildings, bridges, and other infrastructure. This brings benefits with it, such as cost saving, save time, quality of life workflow changes, and paperless workflow. A home automation business can utilize IoT to monitor and manipulate mechanical and electrical systems in a building. On a broader scale, smart cities can help citizens reduce waste and energy consumption. Future of IoT. The future of IoT has the potential to be limitless. Advances to the industrial internet will be accelerated through increased network agility, integrated artificial intelligence, and the capacity to deploy, automate, orchestrate, and secure diverse use cases at hyperscale. The potential is not just in enabling billions of devices simultaneously, but leveraging the huge volumes of actionable data which can automate diverse business processes. As networks and IoT platforms evolve to overcome these challenges, through increased capacity and AI, service providers will edge furthermore into IT and web scale markets, opening entire new streams of revenue. An exciting wave of future IoT applications will emerge, brought to life through intuitive human to machine interactivity. Human 4.0 will allow humans to interact in real time over great distances, both with each other and with machines, and have similar sensory experiences to those that they experience locally. This will enable new opportunities within remote learning, surgery, and repair. Immersive mixed reality applications have the potential to become the next platform after mobile, realized through 3D audio and haptic sensations, and become our main interface to the real world. Bringing future IoT to life will require close synergy between the IoT and network platforms. This continues to be a key focus area of Ericsson research. Future of IoT. Here are 10 predictions about the future of IoT. By 2025, it is estimated that there will be more than 21 billion IoT devices. A quick look back shows where IoT devices are going. Consider in 2016, there were more than 4.7 billion things connected to the internet, according to the IoT analytics. Fast forward to 2021, the market will increase to nearly 11.6 billion IoT devices. Cyber criminals will continue to use IoT devices to facilitate DDoS attacks. In 2016, the world was introduced to the first Internet of Things malware, a strain of malicious software that can infect connected devices such as DVRs, security cameras, and more. The Mirai malware accessed the devices using default password and usernames. What happened next? The malware turned the affected devices into a botnet to facilitate a distributed denial of service (DDoS) attack, which aims to overwhelm the websites with internet traffic. The attack ended up flooding one of the largest website hosting companies in the world, bringing a variety of major well-known websites and services to a halt for hours. This particular strain of malware is also called open source, which means the code is available for anyone to modify. More cities will become smart. Consumers won't be the only ones using IoT devices. Cities and companies will increasingly adopt smart technologies to save time and money. This means cities will be able to automate, remotely manage, and collect data through things like visitor kiosks, video camera surveillance systems, bike rental stations, and taxis. Artificial intelligence will continue to become a bigger thing. Smart home hubs, thermostats, lighting systems, and even coffee makers collect data on your habits and patterns of usage. When you set up voice control devices, you allow them to record what you say to them and store these recordings in the cloud. In most cases, the data is collected to help facilitate what is called machine learning. Machine learning is a type of artificial intelligence that helps computers learn without someone having to program them. The computers are programmed in a way that focuses on data that they receive. This new data can help the machine learn what your preferences are and adjust itself accordingly. For instance, when a video website suggests a movie you might like, it is likely learned your preferences based on your past choices. Routers will continue to become more secure and smarter. Because most consumer IoT devices reside in the home and can't have security software installed on them, they can be vulnerable to attacks. Why? A lot of manufacturers work to get their IoT products to the market quickly. So security may be an afterthought. This is where the home router plays a very important role. The router is essentially the entry point of the internet into your home. While many of your connected devices cannot be protected, the router has the ability to provide protection at the entry point. A conventional router provides some of the security such as password protection, firewalls, and the ability to configure them to only allow certain devices on your network. Router makers will likely continue to seek new ways to boost security. 5G networks will continue to fuel IoT growth. Major wireless carriers will continue to roll out 5G networks. 5G, fifth generation cellular wireless, promises greater speed and the ability to connect more smart devices at the same time. Faster networks mean the data accumulated by your smart devices will be gathered, analyzed, and managed to a higher degree. This will fuel innovation at companies that make IoT devices and boost consumer demand for new products. Cars will get even smarter. The arrival of 5G will shift the auto industry into a higher gear. The development of driverless cars, as well as connected vehicles already on the road, will benefit from data moving faster. You might not think of your car as an Internet of Things device, but new cars will increasingly analyze your data and connect with other IoT devices, including other high-tech vehicles on four wheels. 5G's arrival will also open the doorway to new privacy and security concerns. In time, more 5G IoT devices will connect directly to the 5G networks than via a Wi-Fi router. This trend will make those devices more vulnerable to direct attacks. For home users, it will become more difficult to monitor all IoT devices because they will bypass a central router. On a broader scale, the increased reliance on cloud-based storage will give attackers new targets to attempt to breach. Security and privacy concerns will drive legislation and regulatory activity. The increase in IoT devices is just one reason security and privacy concerns are rising. In mid 2018, the European Union implemented the General Data Protection Regulation. GDPR has led to similar security and privacy initiatives in several nations around the world. In the United States, California recently passed a tougher privacy law. IoT based DDoS attacks will take on more dangerous forms. Botnet powered distributed denial of service attacks have used infected IoT devices to bring down websites. IoT devices can be used to direct other attacks. For instance, there may be future attempts to weaponize IoT devices. A possible example would be a nation shutting down home thermostats in an enemy state during harsh winter. Iot Standard and Framework. There are several emerging IoT standards including the following: IPv6 over low power wireless personal area networks, 6 low WPAN is an open standard defined by the Internet Engineering Task Force. The 6 low WPAN standard enables any low power radio to communicate to the internet, including 804.15.4, Bluetooth Low Energy, and Z-Wave for home automation. Zigbee is a low power, low data rate wireless network used mainly in industrial settings. Zigbee is based on the Industrial Institute of Electrical and Electronics Engineers 802.15.4 standard. The Zigbee Alliance created DOT, the universal language for IoT that enables smart objects to work securely on any network and understand each other. LightOS is a Unix-like operating system for wireless sensor networks. LightOS supports smartphones, wearables, intelligent manufacturing applications, smart homes, and the Internet of Vehicles. The OS also serves as a smart device development platform. 1M2M is a machine-to-machine service layer that can be embedded in software and hardware to connect devices. The global standardization body 1M2M was created to develop reusable standards to enable IoT applications across different verticals to communicate. Data Distribution Service was developed by the Object Management Group and is an IoT standard for real-time scalable and high-performance M2M communication. Advanced Message Queuing Protocol is an open-source published standard for asynchronous messaging by wire. AMQP enables encrypted and interoperable messaging between organizations and applications. The protocol is used in client-server messaging and in IoT device management. Constrained Application Protocol is a protocol designed by the IETF that specifies how low-power compute-constrained devices can operate in the Internet of Things. Long-Range Wide Area Networks is a protocol for WANs designed to support huge networks, such as smart cities with millions of low-power devices. IoT framework includes the following: Amazon Web Services IoT is a cloud computing platform for IoT released by Amazon. This framework is designed to enable smart devices to easily connect and securely interact with the AWS cloud and other connected devices. ARM Embed IoT is a platform to develop apps for IoT based on ARM microcontrollers. The goal of the ARM Embed IoT platform is to provide a scalable, connected, and secure environment for IoT devices by integrating embed tools and services. Microsoft Azure Iot Suite is a platform that consists of a set of services that enables users to interact with and receive data from their IoT devices, as well as perform various operations over data such as multidimensional analysis, transformation and aggregation, and visualize those operations in a way that's suitable for business. Google's Brillo or Weave is a platform for the rapid implementation of IoT applications. The platform consists of two main backbones: Brillo, an Android based OS for the development of embedded low power devices, and Weave, an IoT oriented communication protocol that serves the communication language between the devices and the cloud. Calvin is an open source IoT platform released by Ericsson designed for building and managing distributed applications that enable devices to talk to each other. Calvin includes a development framework for application developers as well as a runtime environment for handling the running application. Pros and cons of IoT. Some of the advantages of IoT include the following: ability to access information from anywhere at any time on any device, improved communication between connected electronic devices, transferring data packets over a connected network, saving time and money, and automating tasks, helping them to improve the quality of a business's services and reducing the need for human intervention. Some of the disadvantages of IoT include the following: as the number of connected devices increases and more information is shared between devices, the potential that a hacker could steal confidential information also increases. Enterprises may eventually have to deal with massive numbers, maybe even millions of IoT devices, and collect and managing the data from all those devices will be challenging. If there's a bug in the system, it's likely that every connected device will become corrupted. Since there's no international standard for compatibility for IoT, it's difficult for devices from different manufacturers to communicate with each other. The IoT brings the power of the internet, data processing, and analytics to the real world of physical objects. An IoT ecosystem consists of web-enabled smart devices that use embedded systems such as processors, sensors, and communication hardware to collect, send, and act on data they acquire from their environments. Smart home appliances, RFID tags, and industrial sensors are a few examples. The Internet of Things helps people live and work smarter, as well as gain complete control over their lives, in addition to offering smart devices to communicate homes, automate homes. IoT is essential to business. Some of the most common benefits of IoT enable businesses to monitor their overall business processes, improve the customer experience, save time and money, enhance employee productivity. There are several emerging IoT standards including IPv6 over low power wireless personal area networks, Zigbee, LightOS, Advanced Messaging Queuing Protocol, Long Range Wide Area Networks, Constrained Application Protocol. Some of the advantages of IoT: ability to access information from anywhere, improved communication between connected electronic devices, automating tasks helping to improve the quality of a business. Disadvantages of IoT is that if there is a bug in the system, it's likely that every connected device will become corrupted. Thank you. CloudLearn Incorporated is headquartered in Silicon Valley, California. Our mission is to help enterprises provide an engaging and impactful learning experience that improves business performance. We provide the industry's most modern LMS. For more information, visit us at www.cloudlearn.com or reach out to us at info@cloudlearn.com.